All right, we've got transformations called dilations now, and the way to remember those is that D sound in dilations might help you remember that you're changing the dimensions. So up until now, we've learned transformations that the shape has stayed exactly the same shape and size. Those are called rigid transformations because we're not changing anything. They're congruent shapes. They don't change the shape or the size. But when you change the dimension, you're stretching a shape, making it bigger, or you're shrinking it down, making it smaller. And so those are similar. So we're not rigid, not being rigid and keeping things exactly the same. We're being a little flexible. We're stretching things out or shrinking them down a little bit. So we're changing those dimensions. So the quick trick on this one is actually really easy. If you can multiply, and usually it's kind of by low numbers, then you're going to be all good on this one. Just multiply your coordinates. So for your ordered pairs inside your X and your Y, inside those parentheses, if you've got a scale factor, that's what they call it, like basically telling you how big or little we're making it. That scale factor, if it's less than 1, we're shrinking the size of our shape. And then if it's greater than 1, we're going to grow the size of our shape. So what you want to do in this example is they'll have that starting point, kind of like I've showed you with other sort of cheat sheet examples, is we've got an X and a Y to start with, and they might say, dilate it with a scale factor of 2. So all you have to do is take X, multiply by 2, take Y, multiply by 2, and that gives you your new point. So with the example of 1, 3, if I multiply 1 by 2, I get 2. If I multiply 3 by 2, I get 6. So that scale factor is telling you everything, right? And it doesn't take a really high scale factor to like really start to expand that the shape that you've got. Stretch it out. So I've just got 3 examples because I think you'll pick it up pretty quickly. If you dilate with a scale factor of 2, so I'm kind of continuing that idea, you might have a line, something very simple like a line, like this line AB. And I've gone ahead and put the coordinates there. It's -2, -3 for A, and B is 0, -2. So if I want to multiply that by a scale factor of 2, right here, okay, -2 times 2 is -4, and -3 times 2 is -6. And then 0 times 2 is 0. That's always nice when 0 is a number. And then -2 times 2 is -4. So now I simply plot those. And by the way, notice it says centered at the origin. If you dilate something that's not around the origin, it gets a little bit trickier, and there's a different way to do that. But for all intents and purposes for 8th grade, we're sticking with dilations about the origin. So if I've got -4, -6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. There's my A prime, and then B 0, -4, 1, 2, 3, 4. There's my B prime. So it took that shape and it made it twice as big, essentially. Okay, so let's do another example, this time with a green triangle. Now it's already kind of big, so I'm glad to see that our scale factor is 1/2. So we're going to shrink everything down. It's not going to be exactly half of it. It's not going to be half the area, but the scale factor is 1/2. So don't expect something precisely half of the area of the triangle. So we've already got our numbers here. Half of -6, if you want to think half of, that's the same thing as dividing by 2. So -6, half of that is -3. Half of 5 is 2.5. So sometimes you might get some fractions or some decimals when you're doing dilations with fractions. Half of -6 again is -3. Half of -2 is -1. Half of 2 is 1. Half of 0 is 0. So now I've got new points to mark on my coordinate plane. So A prime is -3, positive 2.5. A prime. B prime is -3, -1. And C prime is 1, 0. 1, 0. So I'm going to connect these. I got to move my there we go. Now that doesn't look right to me, so I'm going to check my math here. So -6, 1, 2, 3, 5, 6, -5, half of that is -3, up 2.5, -6, -2, -3, -1. I knew I was off. So -3, -1 would have been right here. I did -3, +1. And there, that looks much better. And I'll go ahead and fill that in. Okay. Always check to see if the shape makes sense, because everybody makes mistakes. So myself included for sure every once in a while here too. Okay, so let's do this one with a scale factor of 3, 0, 1, multiply by 3, so 0 times 3 is 0, 1 times 3 is 3, 2 times 3 is 6, 0 times 3 is 0, and so on. And we'll plot those new points. A prime is 0, 3. B prime is 6, 0, 1, 2, 3, 4, 5, 6, 0. C prime is 3, negative 3. And D prime is negative 3, negative 3. And I'm going to connect those points. And there's my new shape.